Okay, so this is the last code-based video of the day, and what we're going to do is talk about the associations between your classes. There are two basic types of associations, aggregation and containment. They sound like large words, but the concepts are actually pretty easy, so let's go ahead and get started. Up to now in our classes, we've been using some simple data types for fields. We've also used simple data types then to express those fields, like properties and methods that only return strings or integers or whatever the case might be. However, when we build classes, we're building custom reference types, just like .NET's reference types. So we can use reference types to define new fields and properties and return values and parameters for methods using these custom types. So in other words, we don't have to just use strings and numbers. We can use we could return a car. Okay, so that's the concept here. So what I want to do is extend or at least rework our car example quite a bit. Let's suppose that for our application we need to keep track of the options in our cars. We have 3 standard engine sizes that each model can have any one of these engine sizes. So first of all, let's do this. Let's create a new engine class. And I've got a couple of options here. Typically what developers do is keep all of their classes in their own files. So in this case we have an auto.cs, I might have an engine.cs, which is probably the route I'm going to go. But I could just as easily define a class right here by going class engine. And now I've defined 2 classes in the same file. It's very possible to do that. For organization's sake and so I can find what I'm looking for more easily within the Solution Explorer, what I prefer to do personally is to right click and select add new class, and we're going to call this engine.cs. Alrighty, and so let's define some public fields. We could use properties, just going to stick with fields for now. Public string size, public int horsepower, okay, so that's what we have. Now let's go over to our assembly line application. We're going to convert this from just being a silly example. In fact, let's do this. Let's blow all this away. Well, yeah, let's go ahead and get rid of it all. We'll start over from scratch. Okay, so let's create 3 engines in our factory. Okay. Alright, so now, and this is the key part, what I want to do is go to my auto class. Go up to the part where I'm defining some public fields, and I'm going to create a new field that is of type engine. It's not of type string or integer, it's of type engine. Okay? You can make these. This is perfectly acceptable. This is the point of this whole demonstration. It looks odd, but it works. Then what we can do in our assembly line is this. Well, let's do this. And that even might look very confusing. How in the world can you have two identifiers representing different things with the same name? In C# you can do this. C# is smart enough to know that this is the type and that this is the identifier that we're choosing to use from this point on. Oops, I just messed up. Okay, so now we can reference it like this. Engine. Okay, so now on the showroom floor we can display the details about the car's engine like this. Alright, so let's go ahead and run the application. So we've just printed to screen the horsepower for the V6 engine for my new car. Okay, so did you see how we were able to access members and kind of chain those together? So first of all, we're going to start with my car. My car has an engine, a reference to an instance of the engine object that's already been created and stored in memory. And then I'm going to continue to chain on and get the property called horsepower from that object that's sitting in memory and then turn it to a string and print it out to screen. Okay, so just to recap here, this relationship between car and the engine is called an aggregation. The car object or the automobile object aggregates other objects like the engine object and potentially other objects as well. So also keep in mind that the auto's engine field is merely a reference to the actual engine that's an object stored in the computer's memory. Even if 1,000 car objects have the V6 engine, there's only one V6 engine object that's stored in memory. You see how that's a benefit? You don't have to create 1,000 different engine objects. They're all referencing the engine that has the exact same attributes. Now, in your particular application, that may not make sense if you want to measure things like engine wear and tear and things of that nature. In my simple application, there was no need for that, so we can all reference the same definition of the three basic engines that we have available. Okay, so let's do this. Let's change this up a bit. Let's have fun and add another class. Called Assembly Robot. An assembly robot will have a single method that returns a car object called assemble car. It returns a type of auto, the auto class. All right, so auto, I think I spelled this wrong. Auto, new car equals new auto. New auto dot model. Sorry, keep mixing here. New car dot model. that's been passed into our method right here. Alright, so what does this assembly robot class do? Well, it basically will encapsulate the process of creating a new car and putting an engine inside of it, and then it delivers the car. Okay, that's what this particular class, this robot I've created, does. So let's change around our program.cs file and tell it, our new assembly robot, what to do. Let's comment out all this. So here we go. Assembly robot. We're just going to borrow this line of code again. Well, actually, we'll borrow both of these. Alright, so let's go ahead and now run the application. And I did this to illustrate, so it returns 500 horsepower. So I did this to illustrate that we can use our custom types to return our methods to return instances of custom types, and how we can use kind of break up the responsibilities into classes to do various things. Now there's a lot of coupling here, because now this assembly robot has knowledge of the engine and the auto classes. Some coupling is okay. Depends on what tasks you delegate for it. It doesn't have any knowledge of the inner workings, except for the fact that we used model, which is a public field, and we probably shouldn't do that. But otherwise, it's able to kind of take on that role in those tasks. So we're going to build on this example later. But you can see from this silly example how we're able to use a custom reference type as both a parameter to our method that we're passing in an engine, and a return value that we're passing out using the return keyword. Okay, so that sums up aggregation, but we're also going to talk about containment, and that'll be the second part of this video. So let me give you another example here. I'm going to go back to my auto class, and here we're going to start off with defining a class within our auto class. Okay, it's contained within it. So here we go. Okay, and so now over here, let's do this. All right, so let's run our application and see how this works. Let's put our read line down here. And now let's run it. Okay, so there you can see what we did was put a class within our class, define a class within our class. This is called containment, and it becomes part of the auto class. So you might be wondering, what's the difference and why would you even want to do this? Well, the difference between association and containment is really a matter of semantics. It's a matter of what makes more sense as we design our application. In this sense, in this particular case, a customer belongs to the car. In the case of an engine, the engine definition is shared among many cars. This, of course, implies that one customer can't own two cars, and if he does, then there will be duplicate entities in memory representing a single person. Keep in mind this. First of all, this is a silly example, and second, it'll often become difficult, if not impossible, and honestly, quite unnecessary to model your class associations exactly how they would be associated in real life. So for our purposes in our application, this model of the associations between the classes happens to work, but it may not work for your particular version of the application. But at any rate, 3 takeaways for this video. First of all, your custom types can be used to define the fields of your other custom types. To say that another way, your custom objects or classes can be used to define the fields of your other custom objects or classes. Typically, this is called aggregation. Likewise, custom types, your classes, can be used as input parameters to methods as well as return types. Okay, we demonstrated that. And third, your custom type or your class definitions can be embedded inside of other type definitions, indicating that the relationship is containment, or to put it another way, there's ownership. Okay, so by now your head might be spinning. Quite honestly, if you're not a little confused by the end of this, you probably weren't listening, or you're blowing off the importance of it. But maybe you're a genius, okay? Maybe you get it a lot quicker than I did when I first learned it. But either way, it's time to start exercising your knowledge after we learn just a couple of more things. First of all, we're going to look at the IDE and learn a little bit more, and then also learn about a notation for objects called the Unified Modeling Language, or UML. And so we'll start down that path in the next couple of videos, and then we're off to our homework assignment. Okay, so that's it for now. Thank you.